What is transformer itself? From the word transformer, it is basically a device that transforms the EMF or voltage of the supply to either a lower level or higher level. But most of the time in Nigeria, what we use is basically what? Is basically step down transformer. Ordinarily, I didn't believe that today there will be questions. I thought there will be questions to solve today. So I said it is a device, I'm still expecting question, not a topic at all. Used for changing or transmitting a voltage supply to the end consumer at a lower or higher or higher form. So basically, you have one of the transformer, one side like that, we have a number of coil, and it is transforming it to another one. Maybe that one is smaller in version. So you expect the output to be lower compared to the one that is given to us the input there. So most of the time what we do is we consider number of coil, then we consider the voltage or EMF. So we have primary, the one that is giving us the source itself. Why is this one that is receiving? The receiver. So it's the secondary. So in this case, we have number of coil for N, here is E. So if we now say that we have the two, so what do we do here? The only formula available here is to say that the EMF of primary over number of primary, number of coil, we have the EMF of the primary over number of primary coil equals the EMF of secondary over number of primary of the what's it called? The number of coil in secondary. Or if you don't use that, if you use I, it will be I, the current of the primary. Now in this case, it will be direct like that. Over number of primary coils equals the number, now it will be vice versa in this case. It will be vice versa in this case. We have IP NS equals IS MP in terms of current. So this is the little I can say about this. If you have any question, please say your question. This is the question. Yes. I believe you can all see the question. It says RLC. This is it. Yeah. RLC. We have the resistor. Yeah. With the inductor and the capacitor, all connected to a source, AC source. And we're told that this one is 100 ohms. This is 3 Henry. While this one is 4 microfarads. Then here we have our source here is 100 volts, where the frequency is 160 per pi hertz. Now, the first question is to find the capacitive inductance, which is what? Which is X. We all know that capacitive inductance is 1 all over 2 pi Fc. Now from here, we have 1 divided by 2 pi times F is what? F is 160 over pi times C itself, which is, oh, let me write the data out. We have R equals 100 ohms. We have the inductance to be the LLL is what? Is 3 Henry, while the C itself is 4 microfarads, which is same thing as 4 times 10 raised to power minus 6 farads. After that, we have our big source to be 100 volts. Then we have, what's it called? The frequency, that one is small letter F, which is 160 over pi hertz. So here we have the F now is written, we have 2 pi, 160 over pi. Then C here is what? Is 4 times 10 raised to power minus 6. If you solve this thing properly, what you will see is that this pi will cancel this pi. Then we'll be having left as 10 raised to power 6 divided by 2 times 160 times 4, which means that this is going to be 1 million.
I have not written the question. Please send it back. I've not finished writing it.
All over, this is 8 times this, okay, 64 times 2, that will give us 64 times 2, 1280. So now this is what we are going to divide now, so that we can be happy. Someone is saying something there. You can't see the question. Let me pick my calculator so that we can be happy. Calculator, come out, come out, come out. Yes. So we have 1 million divided by 1 divided by 1, 2, 8, 0, and that's equal to 782.5. So let's go back to the drawing board. So that is from the calculator there. What we have now is what is 700 and 781.25. 781.25. 781.25 ohms. Second question. Let's see the second question. The second question says that we should calculate the inductive inductance. Who is this? Smart. Why are you drawing on the screen now? Why? Can't be drawing on the screen. So let's go to number 2 question. It said the inductive reactance, not inductive inductance, inductive reactance. Is that okay? This one is 2 pi FL. That's 2 pi times 160 over pi times, okay, you are raising your hand, times 3. Smart, infinite, smart 5, yes, what are you saying? Cancel here. Let's hear you. 2 times 160, 320. So this is equal to 960 ohms. Yes, I can hear you. Can speak out. Infinite smart, you are not talking. Okay, this is not talking, no problem. Let's continue with the question. The third question says that we should calculate the impedance. Okay, that's good. Impedance is the next thing to be calculated here. We want to calculate the impedance there, and that will give us the number 3 things there. Impedance unknown, but the impedance is equal to Z. But impedance equals Z equals R squared plus XL squared minus, who is that? SC squared. What would that be for us now? Our R is going to be 100 squared plus XL, that is 960 squared minus 781.25 squared. So with that, let's take the calculator. The calculator, we have 960 squared 921,600. 921,600. So here we are having this is 10,000 plus 961,600 minus 781.25 squared. That's 610, 351, 5625. 610, 351, 5625. That is 610, 325, 5625. So this is what we are subtracting to get the answer. Oh, it's 351, sorry. 351. Here is 351. So let's subtract to see what that will give us. I'll subtract here directly so that it won't waste our time. We have 961,600 minus 610,351.30000 5625. Let's subtract this. This is going to be 5, 7, 3, and this is 4, 9, 4, 2. We have 1, 5. Then that is what? That is 3. So in essence, someone should have computed the answer for us, rather than me just solving, adding here. So this is 351,249.4375, and that will give us if we add together here, we have the answer to be 361,249.4375. So this is what we are going to find the square root. 361,249.4375. 361,249. So the square root now. Who is that making a noise? This thing will go down soon.
I have to don't go my calculator. Leave me, Joe.
1, 4,
Listen.
2,
Can't remember, okay, please.
5.
Please can't remember.
Point 4, 3, 7, 5. Square root 601.19. 601.19. Six 601.19. 601.19. Did I give the real answer? 249 that you need. Did I get it there? Oh, I wrote wrong thing. It should be 249 here. Okay, let me write it again. 361.249.4375. Square root. 60.04. Okay, still the same thing. Almost same thing. 0.04. So our final answer is going to be 601 ohms. Now the fourth question is to find the current in the circuit. So our current here, that will be what? 4. current unknown. The current now will be Z V over Z. Our V is 100 volts over 601. Now let's go there to see the division. Oh, they took the lights. My system might be off soon. Let me on again. Please give me like 2 or 3 minutes.
I can't see the beginning part of the question, please. Oh, please, resend it.
Yes, I'm back. What's the answer? What's the answer, please? What do you get? Nobody is computing it. We have 100 divided by 601. And that is 0.166. That's 0.166 amps.
Please,
the last question is power dissipated. Power dissipated. Who is that? You are disturbing us. I don't want to mute everybody. That's IV, which is what? 0.166.
Sir, please send the beginning of the question. I'm not seeing it.
Times 100, which is equal to 16.6 watts. Mind you, this thing will go off in the next 5 minutes because I'm not using the normal version, the original one. So this is the end of the solution of the question. The question says that a series RLC circuit comprises a 100 ohms resistor, a 3 Henry inductor, and a 4 microfarad capacitor. The AC source of the circuit has an EMF of 100 volts, frequency of 160 per pi. Calculate the capacitive reactance. Please, it's capacitive reactance, not capacitive inductance. So that's a mistake on your part. Inductive reactance, impedance of the circuit, current in the circuit, and average power dissipated in the circuit. You can see the diagram here. This is the resistor, this is the inductor, this is the capacitor, this is the source, 100 volts, this is the frequency. And to calculate capacitive reactance, we have 1 over 2 pi FC solved to get 7821.25. Then the capacitive, inductive reactance is 2 pi FL, that's 960. The impedance is square root of R squared plus XL squared minus XC squared, and that gives us this 601. For the current, we have the voltage over the impedance, and that gives us 0.166 amps. Then at the end of the day, power dissipated is IV, which is 0.166 times 100, which is 16.6 watts. Now, I told you this is not the original version. It will go off in the next maybe 3 minutes. So when it goes off, you can prolong it back. Now let's look at the next question given to us. Or do you have any issue with the solution? Any issue with the solution?
No, sir.
What's the issue?
So is a problem.
Talk. Because I'm going for the next question. Talk now. This is another question here. He's not talking. And I was expecting her to say something. I said any issue with the solution that you don't understand so that I can explain further. Anyway, the what's it called? This thing will be sent as I'm recording it already. So I will upload it to YouTube and send it to the platform. That is the Telegram platform. If you don't have it, please go and click this. See this one. See this one here. https://g.me/pioneersmp. If you don't have it, you can still get it. You join the group and you'll be seeing the information live and direct. Now it remains like 1 minute, 8 seconds. But let me look at this question. The earth jaw of the submarine has an area of 0.5 square meter. Now, let me quickly write the data. Don't forget, in the next less than 1 minute, this thing will go off. You'll be logging back with the same link. Now, they said that as a specific gravity of, that is the relative density here. The density is 1.03 gram per cm3, which means 1,030 kilogram per cubic meters. Because it's giving us that one in meters, so I have to convert it to that. Now, G is what? G is 10 meters per second squared. This thing will go up soon. So let's relog in. Immediately it goes up. They now say that. So now, I said the other time, the area is given to us 0.5 square meter. Everything that the specific gravity, that means density. So when they use gravity, it means relative density, but it will have a unit of gram per cm cube, which is density. To convert it to kilogram multiplied by 1,000, a kilogram per cubic meters multiplied by 1,000 to get that 1 ton. So, I didn't say per cubic meter here, sorry, per cubic meter. Then we have the acceleration gravity as 10 meters per second squared. Neglect the atmospheric pressure. The force exerted by the sea water on the arch door at a depth of 400 meters is dash. Now, if you look at that religiously, ordinarily, what we are given here is specific gravity. And if you look at pressure, pressure is always equals to what? Force over area. Then it's also equals to rho hg. Is that okay? Rho hg. So now, from what we are given some things here that can assist us. So F unknown, that is what we are looking for. We are looking for the force here. We know the area already. We know the rho already. We are given the H as 200 meters. Then we know G. So with that, our F is equal to rho AHG. Just cross multiply and you get your answer as 1,030 times A, which is 0.5, times H, which is 200, times G, which is 10. And with that, we can see that this thing here is like 515 times 2,000 here. And with that, we'll be saying that multiply again. If I know, oh, I will have multiplied this one here as 100 times this. So that's 1,000. So in essence, what we'll be having is 1,030,000 Newton, which is same thing as 1.03 times 10 raised to power 6 Newton. Now, these are the questions I have here. No more question. No more question. Sending
So how
your
do you
question.
convert cm cube to dm cube by timesing by 100? I thought it's divided by 100.
Oh, yes, that has been serious question from students. Now, what we have here, look at. We have 1 gram per 1 cm cube. Look at that. So it's not 1 gram straight to kilogram. And we are going to kilogram. We are going to kilogram per cubic meters. This one is higher than this one, right? And it's at a lower level. So that is why it will increase it before you know it. So this is going to be, now, let me now give you the solution to the end so that you can get it right. So this will give you 1 gram is empty as 1 over 1,000 kilogram, right? Then 1 centimeter, we know it to be 1 all over 100 meter. So that means 1 cubic centimeter will give you 1 all over 100 cubic meters. So with this is same thing as 1 all over 1 million. 1 million cubic meters. So when we say that we are dividing this now, so to convert it now, 1 gram per 1 cubic centimeter is something as saying that 1 all over 1,000 kilogram divided by 1 cubic meters over 1 million. So it's not only gram we are converting to kilogram. It's because that one is under, which will later move up times 1 million is kilogram over 1 cubic meters. 1,000 we cancel 1,000 here, and we're left with 1 kilogram per cubic meters. I believe you understand that now. Oh, sorry,
Yes,
1,000. I should have written 1,000, not just 1 kilogram. It should be
yes,
1,000.
I understand.
That's it.
Is it that because it's once we have to convert? Is it that because we have to convert to kilogram, which is
That's it.
1,000? You have to multiply by
Exactly.
1,000.
Exactly. So now, any other question? We still have about 39 minutes to end this class. Mind you, there will be math class in the night, 8:30 p.m. to 10 p.m. The same link you use by math Jamb students. I'm still expecting question. Nobody is sending question. That is the question. If the stress on wire is 10 raised to power 7 Newton per meter, it should be Newton per square meter. The unit is Newton per square meter, and the wire is fresh from its original length 10 centimeter to 10.05 centimeter. The young modulus is dash. Okay, let me quickly solve that. Now here it says stress stress here. Stress is equal to 10 raised to power 7 Newton per square meter, while the original length is 10.00 centimeter. The new length is 10.05 centimeter. The extension is actually new length minus original length, which is equal to 10.05 centimeter minus 10.00 centimeter, which is what? 0.05 centimeter. We have to calculate the Young modulus. Young modulus unknown. Young modulus unknown. I like using that for Young modulus. Now, but before we do that, we have to calculate strain. Strain to be calculated. Strain is extension over original length. So that will give us 0. Oh, we have to convert it to meter. This is 5 times 10 raised to power minus 5 meter. Oh, someone might still ask me how I got this. So let me quickly explain better. Oh, no. 10 raised to power minus 4. 10 raised to power minus 4. It's 10 raised to power minus 4. Mm-hmm. 10 raised to power minus 4. Why is it like this? This one is 5 times 10 raised to power minus 2 meters. Then, centimeter. If you have to convert to meter, you divide by 100 again, 10 raised to power minus 2 again, giving 10 raised to power minus 4. So that's why it's 10 raised to power minus 4 here. So this is 5 times 10 raised to power minus 4 over original length, which is, okay, I should have even left it like that. Since both of them are centimeter, let me just leave it like that as 0.05 centimeter over 10 centimeter. So it will give us 0.005 since it is unitless. That's why it has to be like that. Then from there, we have what? We talk about the Young modulus. The Young modulus itself is what? Is defined as stress over strain. In case you don't know the formula for stress, it's just like power. Stress is what? The pressure we did all the time is just force over area. But they have given it to us directly, so we don't need to calculate it. So our answer now will be 10 raised to power. This one now is 5 times 10 raised to power minus 3. So the stress is now 10 raised to power 7 over the strain, which is 5 times 10 raised to power minus 3. If we take 10 raised to power minus 3 up, we have this is 1 over 5 times 10 raised to power 10. It is still Newton per square meter because it will only take the unit of the stress, and that be it. Then from there, we will say that our answer is 0.2 times 10 raised to power 10 Newton per square meter. The final answer is 2.0 times 10 raised to power 9 Newton per square meter. And so do it. Now we have some questions there dropped already. And let me see the questions. How do I solve? If someone said I should talk about mirror, that's a long thing indeed. A long thing indeed. We still have another session tomorrow, 6:30 a.m. by God's grace. so that I can talk about that mirror very well, and you'll be happy with that. So let's see, please, sir. I can't hear you at all. That should be your. You have not connected the. This person here has not connected the audio. If you know the person, please. I can see the person, but the person has not connected the audio. Connect the audio so that I believe you can hear me now. Infinix Hot 8. I know you can hear me now. Annex, you are the one. You are welcome. Okay. Now, okay, let me see. Maybe I should talk about mirror, or I should just solve the question sent there. Which one should I do? How do I solve exponential without calculator? Who is that? Yes. Temple,
I said just solve the question that they brought. The next time can do mirrors.
Okay. So someone said, how do I solve exponential without calculator, especially when solving energy quantization? That's never a problem. Solving that one is quite easy. Very easy. Easy and easy. That one is more of mathematics to say, but let me pick this question, then I will now talk about that one later. There's a question here that is giving us happiness here. I believe you are happy, right? Happy, please. So let's look at the question. But the explanation of the thing is never a problem. I will show you how to do that. That's very easy to do. Okay. So this is the question given to us. But exponential is never a problem. See, something raised to power anything is quite, that is indices. Like, let's say we have 3 times 10 raised to power minus 6 times all divided by 4 times 10 raised to power 2. Here is quite.
Please, how did 0.2 times 10 raised per 10 become 2.0 times 10 raised per 9 the last answer?
Okay. This one. But let me quickly explain this one I was saying so that we can be happy. So this one here, just divide the number directly, and that will give you 0.75. Then here, 10 raised to power minus 6, 10 raised to power minus 2, it will go up. Once it is positive down, it will go up to become negative. That will be minus 6 minus 2, which is what? 0.75 times 10 raised to power minus 8. Because this thing is 0 point, we want to take the number, the point to this place. If you are moving forward, you take the number backward. So that means we are saying 7.5 times 10 raised to power minus 9 in this case. Now this one that we did here is 0.2 times 10 raised to power 10. Because we are moving forward for the point, we take this one backward by minus 1. So that will be 2.0 times 10 raised to power 9 in this case. I believe that one is clear now. Now, do you still have issue on that? I believe that.
Okay, I understand now.
Okay, that's good.
I now understand.
That's good. That's why if you are not a good mathematician or a good mathematics student, it might be difficult to get physics very, because it's full of mathematics. Okay, now let's go there. We have this question that is posted just now by Ms. Tura. It says that an electric generator has an EMF of 240 volts. Electric generator EMF of 240 volts. That's the primary to say. An internal resistance of 1 ohm. If the current supplied, that is I here, is equal to 20 amps. So that is the source. When the terminal voltage O is 220 volts. So we have the voltage drop there. That's 220 volts. They said find ratio of the power supplied to power dissipated. Now, what is the power supply? That's quite easy for us now. Now, from what we have here, what they are saying here is, let me draw the diagram. We have a resistor here. A resistor is there, and we have our cell here. Cell is here, and the source itself is 240 volts. It has an internal resistance of 1 ohm. And here we don't know the resistance, but we know the voltage. We know the voltage to be what? 220 volts. Now, that's across this guy here. So that's why they said the terminal voltage. The terminal voltage is mean here. And a person that understands electricity very well, we know that when you have a closed circuit, the terminal voltage is same thing as the voltage drop across a resistor in a closed circuit. Now the current in the circuit here is equal to 20 amps. Now we have to calculate the ratio of the power to one another. Now, how do we get it? We get it. We don't have to waste our time here. We know the current here. I mean the voltage here. We know the voltage here in the raised source. So that is just it. The power supplied by the generator and the power dissipated. That is the power we really have. We add really is what? So it's going to be easy for you. How? So this is the power supplied. The power supplied will be IV. Let me use IE now. The power supplied by the generator and power used up, dissipated. The power supplied is I times electromotive force, and the power dissipated uses IV. This one. So that will give you I is 20. Just cancel this and this guy here, and we are left with what? With 12, 240 over 220. 0 cancel 0. 2 here 11, 2 here 12. The final answer is 12, which goes to 11. I believe that's one is clear. Now, any other business? If there are no other business, I will just continue with mirror before anybody comes out with something. Now, what is mirror here? Mirror is very easy. I don't know the part that you want in the mirror. If it is plane mirror or curved mirror, which one do you want? Which one? Which one do you want in the mirror? Plane mirror or curved mirror? Curved mirror, okay, that's good. Now, what is a curved mirror? Curved mirror. Mind you, if someone sent in a question that needs to be solved, I will pause it and then go to the question. Now, curved mirror is defined as curved mirror. I always have definition for everything. I like defining everything. Is defined as a mirror Oh, who is that making a noise there? There's a serious noise there. Oh, I have muted the both. It's already moved. So it's you and Nick that disturbing us there. Tell mommy to let you know that you are in a class. Is a mirror cut off from a spherical mirror? Cut off from a spherical mirror. What do we mean by spherical mirror? A curved mirror is just a part of a spherical mirror. Look at the spherical mirror. Spherical mirror is always like this, like a sphere. Now, if you now want to get a curved mirror from it, you cut off part of it like this. So this part that you cut off is now called the curved mirror. Now, the curved mirror is of two types. The curved mirror is of two types. The first one, now before I go there, here is the center of the curved mirror. It's called center of curvature. Center of curvature. It's not the center of the curved mirror. It's center of the spherical mirror. Center of the curved mirror, that one will be defined as pole here, pole. But we are not there, so that one is pole. That's center of the mirror, of the curved mirror. But the spherical mirror is the old one that you now cut from it, the curved mirror. We have two types of mirror here. We have concave mirror. That one is called a converging mirror. Converging mirror. That's the first one. Second one is convex mirror. Convex mirror. Convex mirror, that one is diverging mirror. Diverging mirror. This thing will also go off again. Oh God. Why is this thing giving me stress like this? I think I have to go and buy the Pro. Because in the next 10 minutes, it will go off. Next 10 minutes, it will go off. I will still have about, okay, maybe that will be the end of the class if it goes off, except you call for it. Call for it, no problem. I can still come online. But for now, it's like we are having little time left. Less than 10 minutes to go. Now, what is a concave mirror? Concave mirror. What is it? The way I explain this one is that it is what? It is like a cave. Cave. Got it? Like this. A cave is like a cave where the outside is not what you want. The part that you need is this place. This is the mirror that can see something inside here. Inside here. It's like a cave. When you remember that, you know that we are talking about concave mirror. It can be drawn the other way also. This place is not the mirror part. This place is coated, and you can see from inside here. It's still called cave. Curved cave, that's the way I call it. That's that. What of convex? Convex mirror. What do you call it? Is what curves externally. Convex, X, curve externally. It curves externally. Look at that. If I do like this, so the part that's seeing something is the external part. It curves out. This is the part that's seeing something. This is the mirror part here. Or if I do like this inside, I don't need it because it's coated. This is the part I can see something. I believe that part is clear enough. Yes, it's clear enough. The next thing is to now look at our definition. Definitions, they are easy. Let me just draw concave because I like concave too much. I don't know why. If you have concave like this, sorry about my diagram. 6 less than 7 minutes. If I draw like this, straight like this, here will be pole. Here is where we have the principal focus. Here is center of curvature. Now, the definition we have, let me take the first one. Center of curvature can be defined as a central point of the spherical mirror from which the curved mirror is cut off and it's number 2 there is principal focus. That's A. This can be defined as a point where reflected rays converge or appear to diverge from, or appear, oh sorry, there's a code there that is disturbing my internet. Appear to diverge from after reflection. You can see that as taking care of both the converging and diverging mirror. Both. So the third thing you need to get here is pole. Pole P. That is the central point. Central point of a curved mirror. And you can see there is P is here, P here. Then we need to know the first thing, that is radius of radius. R. This is what we call the distance between the center of curvature. I won't write that one now, and the pole. That is from here to here. That's R. While the fifth one is what we call focal length. That's the small letter F. Is what is the distance. This is the distance. The distance I need to draw this definition because it's necessary for us to draw ray diagram. Because I know what we want is ray diagram. How do we draw ray diagram? Between F and P. That is the center, is the middle way. Middle is just half of the what? Of the radius. So here we just say that R equals to F. R equals 2 times focal length. While the focal length is radius over 2. Then from there, we can take the sixth one. Sixth one here is the principal axis. We call it principal axis. That one is the line. Now, joining the center of curvature, the principal focus and pole together. This line is what we call principal axis. Now it's just 1 minute 20 seconds. I don't know. Do you want me to continue maybe for the next 30 minutes so that we can get something right? Or we should just leave it for tomorrow so that we can discuss better. I've seen a question here talking about the gravitational field. It's gravitational field. It's gravitational field. It's a gravitational question. I will copy the question. So I can't do justice to the question now because of time. It's just about a minute, less than 1 minute. So what do you say, my people? Should we just continue tomorrow or we'll still continue? Some of us are still going to lesson today by 9. So let's just stop at this point. By next class, tomorrow, same 6:30 a.m., we are going to do justice to everything, both the curved mirror, now this has been the end of the first part of this free Jamb class. If you are still there doubting that what they are doing there is a child play, quickly join us in the night today for the maths class. It is free for all. Just send in your question will be solved. Tomorrow morning we still meet again by 6:30 a.m. to 8 a.m. for physics again. Basically on physics Jamb. Send your question and it will be solved. You can see many questions have been solved today. So we'll continue with this next class by tomorrow morning with physics. But this night today by 8:30 p.m. to 10 p.m. we'll be having maths. So I remain your one and only maths and physics coach, the Pioneers Maths and Physics class on the YouTube channel. And just like I said, if you want to join the Telegram, that's where you get the first hand information anytime. You can easily come to us here. You will get the real information immediately. And if you are new to this channel, quickly click the subscription button and also the notification bell so that you can be informed immediately the information or a new video is dropped. So this is the link to the Telegram. You get your information immediately. I remain your man. See you when I see you. And bye for now.